Okay, thank you. So this is the outline of what I'm going to be talking about. And first I'm going to kind of define the type of cover crops that I'm talking about and that we've been researching and doing on-farm trials. And I just came up with the word high output cover crop. So I'll define that in a minute. But basically we're just talking about a productive cover crop that's going to have substantial growth in the fall and offer certain benefits to the cropping system. So, and then I'll talk about the savings by this type of productive high output cover crop. And those include many things, but I'm going to focus on nitrogen cycling and nitrogen scavenging because that's what I've been working on. But then I'll also mention other nutrients that the cover crops can scavenge, how they can alleviate compaction, and that can translate into cost savings, and they can also help to control weeds, so that may reduce on herbicide applications. And so those are some savings of cover crops that I'm going to talk about, and then the cost of cover crop. I mainly focused on the seed cost and the cost to plant the cover crops, the application costs, and then kind of the overall balance of whether or not the cover crops are going to pay off by themselves or not. So high output cover crops. Essentially, I just wanted to make the point that all cover crops are not equal. So an early planted cover crop is going to have a lot more benefits than a later planted cover crop. So this was a cover crop that was on a farm trial that we did in Lancaster County, Pennsylvania. And this was a farm with a history of heavy manure, and they got the cover crop planted by September 2nd. And that cover crop, you can see all the growth and how big the radishes were. And this here was a mix of radish, triticale, and crimson clover, is what the photo is showing. And that mix took up about 150 pounds per acre of nitrogen. So overall, the cover crops on that farm range between 130 and 180 pounds per acre of nitrogen that was taken up. So that's what I'm referring to as a high output cover crop in comparison to, and that's actually a really high output cover crop. It doesn't have to be quite that high, but that's in comparison to something like this trial, which was in Prince George's County, and this was on a sandy parent material. And here the cover crop got planted late by early October, but it only took up 4 to 7 pounds per acre of nitrogen. So just a huge difference between what the cover crop like this is capable of doing to the soil and nutrient uptake, etc., compared to what a very productive cover crop is going to be able to do. So I'm defining high output by having more than 1,000 pounds per acre fall biomass growth. Typically in this region they're planted by mid-September in Maryland and southern Pennsylvania, which is where we've been running trials. And then also they're going to include something in addition to or other than a winter cereal, because we're finding this pattern repeatedly of the winter cereals holding on to the nitrogen in the spring and immobilizing that nitrogen, and this either requires higher nitrogen applications to the following corn or a decrease in the corn yield. And so we think there's a lot of potential for cover crops that may be a mix of a winter cereal and some kind of a brassica and or legume. Okay, so these are just some of the advantages or ways that a high output cover crop could pay off. This picture here was from a field day we had on November 1st, about a week ago, and that cover crop was again the mix of triticale, radish, and crimson clover, and it was planted by early September. And that radish root, you can see the radish root going down, that went down about 4 feet, the taproot from that root. And the triticale roots were going down at least 2 feet. And so that's going to help with all kinds of aspects of the soil. That's going to be scavenging deep soil nitrogen and other nutrients. It's going to be adding soil organic matter and carbon to the soil and helping the soil biology and the health. And also, if you have species like that radish are going to be reducing soil compaction and helping water infiltration through the root networks. And then all of these factors are going to have some kind of impact on the following crop yield. So that's what I'm kind of referring to when I say these productive, early planted, high output type cover crops, something that's going to affect the whole overall system and the following crop yield as well. Let's see here. Okay, usually this next set of slides I kind of wait to the end of my presentation and throw them in. But I wanted to put them up front because I wanted to emphasize that the cover crops can be fit into a row crop system. So a lot of times people get scared off when I say the cover crop should be planted by early September, because that doesn't fit too well into a row crop system if you're not harvesting the corn till late September and the soybeans till October, even into November. How do you get a cover crop, a high output cover crop, planted early enough in that system? So I wanted to just go over briefly some techniques of management ways to get the cover crop planted early. And some of these we've studied in our lab, and some of them we haven't, but I just kind of wanted to give you an overview of them. So the cover crops can be planted after earlier crops such as corn silage or potatoes, or there's been some success planting shorter season corn varieties. So maybe not all the fields, but on a select field or rotated field on the farm to get an earlier corn variety in could provide a good window to get an early cover crop and a very productive cover crop that will pay off. And then sometimes it would make economic sense to skip a double crop of beans and to plant a highly productive cover crop in July after wheat. And then some other ways that could go into a more conventional corn and bean field for grain would be to aerial seed the cover crop on into the standing grain. So this has been pretty successful in Maryland. It's kind of hit or miss depending on the rain. So we found that if the farmers have irrigation, it can really pay off to run the pivot ones on top right after the seed has been flown on to provide that seed to soil contact. But in general, the aerial seeding has been pretty successful, and I'm going to show a bunch of pictures of that in a minute. First, I want to show this trial, which we did in Caroline County, Maryland. This we compared aerial seeding the cover crop into a standing corn crop in early September versus drilled in October. But the aerial seeded, we had it without irrigation and with irrigation. So on this farm, we found that flying the seed on didn't really give you an advantage. On the y-axis here, we have pounds per acre of nitrogen uptake. So flying the seed on didn't really give you an advantage in this case unless you also irrigated. And that's when you got that more productive cover crop, because they didn't have rain that year right after they flew it on. So that can really, the irrigation can really provide an insurance to get the more productive cover crop. And then over here, there can be differences with species take with aerial seeding. So here he grew barley, but you can see the yellow is the weeds, so the barley was actually more weeds than barley that came up when he aerial seeded that. So these are some pictures from about a week ago on the Eastern Shore and various farms. These were aerial seeded cover crops flown on in early September. So here you see, these were not irrigated. So here you see that we got a pretty good stand this year, aerial seeding. And this is a comparison between aerial seeding on top of standing soybean and drilled after the harvest of soybean. So soybean is especially important. I'm going to talk about that in a minute because we're finding really large pools of nitrogen after growing soybean in the soil. So getting a good cover crop established after soybean can be particularly important, but it's also harder because the soybean's coming off later. So, but this was pretty successful, aerial seeding it into the standing soybean. So that was aerial seeded and really focus on the root, so that we have much more root development for the earlier planted. And this was a mix, again, of triticale, radish, and clover. This next slide shows just the straight triticale. And this was also flown on. On the left now is the flown on, the larger one. And look at the root development on that one compared to drilled after the harvest soybean. So this is just going to have many more benefits to the soil overall when it's flown on earlier. These next three photos, I'm just going to show some different establishment techniques. This was a farm that we were working at in Dorchester County, and he was trying some different establishment techniques. So this one was the cover crop drilled after the corn harvest in early October, and we had very minimal growth in the fall. These pictures were taken in December, and this was a radish, wheat, and a winter pea mix. And then right down the road, the same farmer but a different field down the road about a mile, this one he broadcast the cover crop seed. It was wheat and radish, and then he stalk chopped on top of that. And that was planted on September 20th, so about 2 weeks earlier than the last photo I showed. And that one was doing much better. You can see the tubers are developing and the radishes. When the radish was drilled, it was no tuber development, very little root development on the last one, but here we have much larger cover crops. And then this was a field about a mile down the road, and that one he flew on in late August. So there you can really see the productive cover crop and the large radish and wheat that was taking in that field. Okay, some other techniques to get cover crops planted early and to have the more productive cover crop. You could interseed them. So this shows a high boy seeder with drop down nozzles. That could be one method. And right now we don't have one of these for rent in Maryland, although I found this photo really interesting. I had to include it. It was just something that came up on Google, but this was a high boy interseeding cover crop into a cornfield in the 1960s in Maryland. So people used to have this equipment, and I think there's potential for it to be really useful. I think they're renting one out in Delaware if they're looking at it. And then you can interseed early on at nitrogen side dress time. So this was some equipment developed by Penn State University, and you can plant the cover crops at the same time as the nitrogen side dressing or applying herbicide, kind of combine some trips through the field. And that has been relatively successful, especially under the corn canopy where you get some light penetration. The soybean with the closed canopy is kind of hit or miss. They had some mixed results whether the cover crop would take under that. But then if you don't have this fancy equipment, you could do an air seeder, like Kevin did at our farm in Beltsville, Maryland, at the University of Maryland Research Farm. And we just seeded that using this, and the seed kind of flies out and hits that metal plate and goes down. And we had a pretty good stand using that in the soybeans. We did that into soybeans. Okay, so that kind of ends where I'm going to talk about what is a productive cover crop and how to get a productive cover crop planted early. And then I'm kind of going to go into the cost savings that are offered by these high output cover crops. So I'm going to focus on the cover crops being able to scavenge deep soil nitrogen and bring that nitrogen back to the soil surface and release it. So the cover crops being a source of fertilizer for the following crop. I'll focus on that because that's what I've been doing most of my research on. But then I'm going to mention some other benefits of cover crops and how they can pay. They can alleviate compaction, which may save you having to subsoil. They can control weeds, which in some systems could save an herbicide, and then a few other benefits that I'll go through briefly. So scavenging and recycling deep soil nitrogen. Before I talk about the cover crops, I'm going to take a step back, and we were interested in this question: will cover crops be able to scavenge deep soil nitrogen and bring that back to the surface? But first we wanted to know how much nitrogen is left at the end of the growing season. So after corn and soybean finish taking up their nitrogen, is there nitrogen in the soil profile left or not? So is there nitrogen to be scavenged, basically? And so we took deep soil cores and transects across farm fields, and we looked on 29 farm fields. These were in Maryland on the eastern shore on more sandy coastal plain parent materials, and then in Maryland on residual parent materials and up into Pennsylvania. And on each farm we took a series of deep soil cores. We went down to 7 feet, so 0 to 7 feet, and we looked at how much nitrogen was left. And we took all of these in late August into September, so after the corn or beans had finished taking up nitrogen for the year. And we found, on average, 226 pounds per acre of mineral nitrogen, nitrate plus ammonia. 100 pounds of that was nitrate, and about 120 was ammonium. And we think the nitrate is leaching through the soil pretty quickly and getting replaced each year, whereas the ammonium is staying in place longer due to cation exchange in the soil, so that's not leaching through as fast. And then over half of that nitrogen was in the lower meter, so it was 3 to 7 feet deep. So we found about half of it in the top meter, and the other half was lower in the soil profile. And it's important to note that the lower the nitrogen is in the soil profile, the more likely that is to leach out of the system and to be lost over the winter. So, and then we also found higher soil nitrate after soybean than corn. And I have a graph of that I'll show here. So this is showing the amount of nitrate and ammonium after growing corn versus after growing soybean. So on this past year, on 4 farms that had side-by-side corn and soybean fields, we took deep soil cores in the corn and in the soybean, and we compared them directly. And we found that the nitrate, so this graph shows the soil depth from 0 down to 210 centimeters, so the top 2 meters of soil, and then the amount of nitrate that we found in that soil. So we found higher nitrate following soybean than following corn. So there's higher nitrate following soybean, which had no fertilizer applied to it, than following corn. Probably because the nitrogen in the system is mineralizing, and of course the soybeans are fixing nitrogen from the atmosphere. But that's a really important pool of nitrogen. It's deeper in the soil profile, so it's at risk to being lost. So we think it's really important to try to get a cover crop into that system, even though it's tough because the soybean's not harvested till later, but to get a cover crop in to try to scavenge and recycle some of that nitrogen before it's lost following soybean. And then I just wanted to show this. This is just the variability. These are the 29 farms where we took the deep soil cores, so it was variable, the amount of nitrate and ammonium left in the soil profile. Some of the farms had about 100, so this is the kilograms per hectare of the light blue is nitrate and the dark blue is ammonium. So all of the farms had at least about 100 kilograms per hectare, which is similar to pounds per acre. Pounds to acre, it would be about 90 pounds per acre. All of them had at least about 90 pounds per acre in the profile, and some of them had much more. Okay, so that answered our question. Yes, there are large pools of nitrogen left after growing corn or soybean, and so then we hypothesized that if we planted these cover crop systems, this high output type of cover crop, by early September, it could scavenge that nitrogen from the deeper soil layers and that nitrogen, and take that nitrogen up into the cover crops. And then if we included certain cover crops such as the brassicas or legume, that nitrogen would decompose with the biomass, or be released as the biomass decomposed, and be on the soil surface available to be taken up by the following corn crop. So that was kind of our hypothesis in this cover cropping system that we were trying to investigate and with the research and the on-farm trials. Yeah?
Would you worried about, or have you looked at any of the possibility if it was say, an early kill of the radish and any early leaching of the nitrogen before the crop was planted?
Right, so that's a legitimate concern that a lot of people bring up. And on one study that our lab did in the past, we did find on a very sandy soil, and this was a site where they had killed soybean in August to put the research plots in. So it was a high nitrogen environment, and in that site we did find that the nitrate had leached down into pore water at 90 centimeters by planting time. But on a lot of other sites, we're not finding any nitrate in the pore water. And even this past year, we looked at a site in Kent County, and we compared the radish and a mixed cover crop and a triticale to a no cover crop. And in the no cover crop, there was nitrate in the pore water at 90 centimeters, but there wasn't any in the, or very little in the, even in the radish.
You think it stays pretty stable?
It seems to be pretty stable, but on certain sites we did find that, so it's not 100% for sure. Yeah. Okay, so this is kind of the motto of this project. The farmers have been putting these signs up, our cooperating farmers, adding nutrients to your bottom line, not to the bay, because we kind of have this dual purpose of preventing nitrogen from leaching, but also trying to recycle that nitrogen and allowing the farmers to use that to reduce fertilizer requirements for the following crop. I'm going to go through a few studies of the on-farm trials that we've done and the results that we found from there. This one was from Lancaster County, PA. This field had a history of heavy manure, and the cover crops were planted on September 2nd. So this was one of our more productive cover crop stands that we had. And we took biomass samples. So the y-axis here shows the nitrogen uptake in pounds per acre. And this, basically, we just harvested the quadrat, so we knew how many pounds of biomass material we had, and we multiplied that by the percent of nitrogen in the material to get pounds of nitrogen per acre. And then the different cover crop treatments that we looked at. On most of our on-farm trials, we looked at a pure radish, some kind of monoculture of a winter cereal. So the farmers decided that it was either rye or triticale or wheat, or one farmer did oats. And then a mix, which was the radish plus the winter cereal plus a legume, and usually they did crimson clover. And then we always compared it to a no cover crop control. So the radish here took up 166 pounds of nitrogen per acre. The triticale took up about 140, and the mix took up 181. And then I just put, so I'm going to talk in a bit about our corn yield trials following cover crops. And then I think these nitrogen values will make more sense. But pretty much we're finding that after a radish cover crop, you can maintain yields by reducing the fertilizer inputs. After a mix, you can't reduce fertilizer inputs, but you also don't have to do extra fertilizer. But then after a winter cereal like the rye or triticale, in order to maintain the high yields, you have to apply more fertilizer. So that's the data I'll show you in a minute, but just for here, I don't want to, throughout the presentation, I'm trying to put values on these values of the cover crop. So I don't want to give a value of money for that nitrogen that's being taken up by the mixed cover crop, because that doesn't really seem to mean that you can apply less nitrogen on the following corn. But the radish, you can apply less nitrogen on the following corn. So there I'll say that that's $29 if half of that nitrogen that was taken up by the radish is available. And then in the spring, these are the pounds of nitrogen per acre for the different cover crop treatments. The radish winter kills, so that's not on the chart, but the triticale had almost 200 pounds of nitrogen per acre, so it continues to take up nitrogen in the spring, but that nitrogen is being immobilized, which we'll get to in a minute with the corn yield. The mix had all of that radish decomposed, so that's why that one went down to about 60 pounds in the biomass. And then the control in this study had a lot of winter annual weeds, so that's why that one is so high. And I'm going to talk about weeds in a minute. So here's two similar studies, same setup, same 4 treatments on the eastern shore. One was in Dorchester County, and this one here was in Kent County. And here we found less overall biomass of the cover crops and pounds of nitrogen taken up because of the difference in the soil types, and there was less manure applied at this site, but still we're finding 73 pounds of nitrogen per acre taken up by the radish. This is in the fall, so these are when we measured in December, and then 54 pounds by the mix, and this was wheat at this site, and that took up 26 pounds of nitrogen in the fall. And then in the fall at the Kent County site, we found 33 pounds taken up by the radish and 18 by the winter cereal and 33 by the mix. Here we had a mix that was planted at the same time as the radish and the winter cereal, and we also planted a mix 2 weeks later. So we see that drop off. The later the planting date, the less productive, less biomass, less nitrogen uptake of the cover crop. So overall, as I mentioned, the radish is going to be releasing that nitrogen it took up, so we can count that as cost savings. We can reduce the nitrogen fertilizer following radish. The winter cereal is going to be tying it up, so we'll have to apply extra nitrogen, and so I call that a loss of money. And then no cover crop tends to be very weedy. That's the no cover crop in comparison to the radish. So, and we see that over and over again on these trials where the radish is giving you a clean soil and you have all these winter annuals with the no cover. And then the mix is kind of in between. It's similar in terms of the nitrogen that it's going to be releasing for the corn. It's similar to not having a cover crop. It's not tying it up, but it's also not necessarily going to release it. It kind of varies by what species and the planting date. Okay, so on these farms we also took deep soil cores using these Vehemeyer probes, and here's what we're finding in the soil profile under these different cover crop experiments. So the y-axis here shows the surface down to 7 feet deep, and this is, and the x-axis shows the amount of nitrate in pounds per acre that we're finding in these different soil layers under the different cover crop plots. So the black line is the control. So we find a lot of nitrate on the surface where there was no cover crop, and these samples were taken in November. So in November we have this large pool of nitrogen on the surface where there's no cover crop, and all of the cover crop treatments cleaned up the soil profile of nitrate. So it didn't matter if it was a radish or the mix or the triticale, they all had similar amounts of nitrate, and they all had much less than the control where there's no cover crop. And there were significant differences all the way down to 180 centimeters. So the roots are growing down really deep in the fall months. If this one was planted on September 2nd. Now in the spring, this was interesting because the control, which is the black line, now we have what used to be a bulge on the surface layers. Now that nitrate, you can see, is leached down and is about 60 to 150 centimeters deep. So between November and April, that nitrate that was on the soil surface has leached down quite a bit into the soil profile. And the radish has now released its nitrogen on the soil surface. So the radish winter killed over the winter, and it releases the nitrogen mostly in the form of nitrate. And you have this large pool of nitrate on the soil surface. in these top 2 layers, so the top 2 feet here. And then the triticale retains that nitrogen, so that's still holding on to the nitrogen and immobilizing it. And then here for the costs, I just assumed that if this nitrogen that was taken up by the radish, so this is in nitrate form, so that should be available for the following crop. And this treatment had, where there's a radish, had 110 pounds more nitrogen than the triticale or control treatments. So that would, if that nitrate was available to the following crop, which it should be, then you're saving, you can reduce the fertilizer application and save $38.50 in nitrogen costs. So I'm going to briefly go over another study that we're looking at the rooting depth and the scavenging of the different cover crops. So this we're using nitrogen 15, which basically is just a heavier version of nitrogen, and it allows us to bury it at a certain depth and to track how that nitrogen then moves up into the plant roots, and we can then go back in and take samples of cover crops that we planted on top of where we buried it, and we can test that for the presence of that nitrogen 15, and if it has the nitrogen 15 in the sample, then we know that the roots got down to where we had buried it. So that was the idea behind this experiment, and using that technique, we found that if the cover crops are planted by early September, they'll capture nitrogen from up to 180 centimeters deep by December. So we found that heavier nitrogen, that tracer, in the radish, not in the rye, but in the radish in December from 180 centimeters deep. So those roots are going down 180 centimeters. But that's if planted early. If planted later, we found that the cover crops are only capturing nitrogen from 60 centimeters deep, and they did not get it from those deeper layers. And then we also took more samples in the spring because we wanted to know if the cover crops are planted later and they're not getting to that nitrogen in the fall, will they get it in the spring? If we let them grow in the spring and they have substantial spring growth, will they get it then? And we found that they didn't. So if they didn't get it in the fall, so for example, the October planted cover crops, if they didn't reach that nitrogen from 120 centimeters in the fall, they also didn't reach it in the spring. So they were not able to catch that nitrogen because the nitrogen is also leaching down through the soil profile. So it's kind of a race between the nitrogen leaching down and the roots growing and the nitrate one. The roots weren't able to get it by the spring. And we found similar uptake patterns between the radish and the rye and the mix. The radish got slightly deeper than the rye. And in terms of being released to the following corn, so on these plots, after we grew the cover crops, we let them, we killed them or let them decompose in the case of the radish, and then we planted corn. And we actually found trace amounts of the nitrogen 15 in the corn at V5 stage. So that told us that in the mixed and the radish cover crops, but not in the rye, those mixes in the radishes were decomposing, and that nitrogen was taken up by the corn because we found it in the corn. So this just shows the difference at that study between the early planting date and the late planting date. That's actually a radish in my hand there, if you didn't tell, which is the big difference between 1 month of planting. And that's why we're seeing these differences in the rooting depth and the ability to capture the deep nitrogen. Okay, so the effect on the following corn yield. So we want to know so the cover crops can capture the nitrogen, but is this nitrogen going to be released to the following corn, or is it going to be immobilized and not available for the corn? So on where we had our cover crop trials, following the cover crops on several of the sites, we planted corn and we measured the weight of the corn at V5 stage, so early on in the season, and then again we measured the corn yield. And we found at V5 stage we have this pattern of the radish having larger, healthier V5 plants, in comparison to the no cover and the mix. The no cover and the mix were similar. So in terms of the size of the corn at V5, no cover is kind of like having a mix. But then the winter cereal was a little bit stunted, and we had smaller plants following the winter cereal at V5. Now this was no starter nitrogen applied, so we wanted to see the effects. How did that translate to the corn grain yield? So this is a nitrogen response curve. We have the yield on the y-axis and then the nitrogen fertilizer applied on the x-axis. And this was, we asked the farmers to do half of what they normally would apply, which in this case was 60 pounds of nitrogen per acre. 120 was his normal rate, and then 1.5 times what they would apply at 180. So here we find that these patterns are continuing, the early season patterns are continuing. All of this nitrogen was applied at side dress time, not at starter. So I'll mention that in a bit. But for here we find that the radish has a higher yield than all of the other, the corn following radish has higher yield. The mixed cover crop is about similar yield to not having a cover crop at all. And then this winter cereal cover crop tends to immobilize the nitrogen, and you get a yield hit. Now this yield hit probably would not be there if we had applied starter nitrogen. So I don't want to make it sound like you're always going to lose money planting rye, but if you apply starter nitrogen, that's an extra expense. So we're thinking either you're going to have to apply more nitrogen, which is going to be an added expense with the winter cereal, or in order to retain, or have a yield hit. So in order to retain these higher yields, it's important to have some other species mixed into the cover crop if you don't want to apply more nitrogen at the beginning. And that was just another site, similar findings. In this case, the only cover crop species that resulted in higher corn yield was the radish monoculture, and the mix and the triticale cover crop species were both had a yield hit in comparison to no cover crop at all. So overall, this is a study from the literature, and overall, this is the corn yield following winter cover crops for the different types of cover crops. So, and this is the y-axis, the x-axis is the nitrogen fertilizer rate applied. So as you increase the amount of fertilizer applied, you always have this benefit of having a biculture. So in this study, the biculture meant a winter cereal and a legume. So the mixed cover crop always resulted in higher yield than the winter cereal alone, regardless of whatever nitrogen fertilizer rate they were applying. And then for the legume, the pure legume cover crop, kind of as you would expect, as you apply more nitrogen fertilizer, the corn yield went down for that, or the corn yield response. So the legumes went down. But we're really keyed in on this mixed cover crop, and we think that can result in yield benefits and cost savings. Yeah?
Well, by culture, do you mean usually a grass and then a legume?
Yeah, so in this study, it was all like a grass and a legume. Mm-hmm. Yeah, okay. So I'm going to go through some other savings offered by cover crops much more briefly than the nitrogen. So the cover crops can, if it's a legume, of course you can add a lot of nitrogen to the system, and organic farmers are very familiar with that. So can add 100 to 150 pounds of nitrogen per acre, which translate to be $35 to $52 in savings of less fertilizer that you have to apply. Cover crops can alleviate compaction. So that can reduce costs by not having to subsoil the field. So in our lab, before I came, they did a lot of work on looking at the bio-drilling of the radish cover crop. And they found that the soybean roots can actually go down the pores made by the brassicas. So this was not a radish, it was rape, but they put little video cameras down into the soil, and they actually captured the soybean root going down the same channel that the rape root. I'm glad I wasn't the one looking through all that footage, but it probably took a while. But then they did a study looking at the compaction of the field and the ability of radishes to get through that compaction. So here's a radish growing in the non-compacted field and a radish growing in the heavy compacted field. But even in the heavy compacted field, as you can see in this next slide, the radish roots were able to get down. So the tuber gets kind of crunched up on the top, but the tap roots can go down into those deeper soil layers and break up that compaction. So here's comparing forage radish, which had much more roots in deeper soil layers than the rye, especially than the rye or even than the rape. So the radish has been really effective at that bio-drilling and breaking up compaction. And that resulted in an extra 1 to 5 tons of silage for the following corn. Okay, so you can save money potentially on not having to subsoil. So the numbers I found from Maryland Extension was that subsoiling costs $24 per acre. So if you have a radish growing in that field, you could rotate the fields through. You wouldn't need the radish every year, but then if you rotated a radish through, then you could really save on not having to subsoil. Okay, so cover crops can control weeds. And I already mentioned this earlier, so there again is the difference between no cover crop versus a radish cover crop. And you wouldn't always be saving on weed costs, but if you were able to get away with planting one less round of, say, Roundup, this is what I calculated it out to be, that you would be saving $13 to $17 per acre by one less application of Roundup. And this is just showing that the weed cover radish is particularly effective if the radish is planted early. So these are weeks after August 20th. So as you get into September and October, planting the radish in September and October, it's not going to have that same effect on the weed control. Okay, so some other benefits that I'm not going to show any data for today is the cover crops can take phosphorus and especially sulfur. They're really good at scavenging sulfur, which can reduce fertilizer needs, help with soil erosion. They could have a grazing value if you have animals integrated in. With organic systems, especially that weed control can be particularly important as a good savings in organic systems. Soil health, carbon inputs, increasing water infiltration, and reducing runoff. So the cost of cover crop seeds, these values I got from a SARE publication. So this was kind of the average that they collected from many sellers that they questioned about the costs. And to figure out these costs of cover crop seed and planting, I multiplied the seed cost by the recommended rate of seeding. So if you're drilling versus broadcast and aerial, you're going to do a lower rate for drilling than broadcast and aerial. So I took that into account, and then I added the cost of application. So for drilling in Maryland, they say that it costs $20.33 an acre, broadcast $8.91, and aerial was $21.50. So these values here is what it would cost to plant an acre of cover crop of these different species. I did the radish, the rye, and the mix that I've been talking a lot about, the triticale radish clover mix. And this is what it would cost for the seed and to apply the seed in these different methods. these are just some other costs per acre planting other seeds. So I'm going to skip through these, but I'm going to show you the resource. So if you're interested in that, it all comes from this book, Managing Cover Crops Profitably by Sayre. I already talked a lot about the costs and the benefits. So then I wanted to just mention this in summary, that really to get cover crops to pay, that you have to plan for them like you would a cash crop. So look at the field and decide, what do you want the cover crop to do in this field? Does this field have a lot of nutrients left that need to be recycled? You could look at the soil test. Do you want to alleviate compaction in that field? Do you have problems with water availability or a weed problem? And then just kind of look at the field and decide what cover crops will help to manage that and what your cover crop windows are, and try to get the cover crop in to do work for you in a particular location. So not every practice is going to be relevant for every field and every year. Like you may only want to use radishes to biodrill every few years if you're having issues with compaction. And you may not see the benefit in the first years. It may take a couple years or several years before it really starts to pay off. And then, so here's the source that I got for my values for the different Maryland cropping practices, the corn yield and the nitrogen fertilizer costs and the subsoiling values came from this Maryland Extension website. And then the cover crop information came from this book, Managing Cover Crops Profitably by Sayre. And then I just wanted to mention the elephant in the room, which is, of course, in Maryland and Delaware, you can get incentives to plant cover crops. So this is the table from 2017 for the incentives to plant a cover crop. So these are, we do think that cover crops can pay by themselves, and even in states where there's not incentives, that they will pay for themselves. But in Maryland and Delaware, you have these extra incentives that even provide the insurance for, or kind of like a source of insurance for planting the cover crop, where you have this extra money coming in for them. So, not sure if I have time for questions.
We've got about 2 minutes for questions. If anybody has any questions for Sarah.
Yeah.